Hey guys, welcome to lesson 5.2.1. We are going to kind of switch gears here, but also go off of the idea of finding inverse equations. That's kind of the base here that we're working off of. And we're going to use that to introduce a new idea called logs, and we'll see how those go hand in hand with these exponential functions and the idea of inverses. So the first thing I want to do is take a look at this function right over here. It's an exponential function, and the reason that it's an exponential function is because there is a variable in the exponent. Anytime you have a variable in the exponent, that is what you call your exponential function. So I want to start by making my tables for the original and the inverse, and then I also want to make the graph. So I have graphed it here in my calculator. I typed in 3 to the x, and the way I did that was I just did 3 with the caret key, and then that's how I got the x there. Okay, so I can go ahead and go straight to my table. Here I have -2, -1, 0, 1, 2, so those are the numbers that I'm going to focus on here. Alright, so we got 0.1111, 0.3333, 139. Okay, and then I can go ahead and graph that too while I have it. So I'll, and you know, keep in mind this is going to be hugely an approximation, so I'll go, you know, guess like where 0.111 falls. It's probably going to be somewhere around there. Same with 0.333. 0, 1, 1, 3 get easier, and then 2, 9 doesn't really fit on our graph, so we're just going to go ahead and draw our curve with what we have. So now for the inverse table, we actually can just do it without doing any work. If you guys remember, we could just flip-flop these numbers, right? So I can take my -2, 0.1111 and turn it to 0.1111, -2. All right. So now that I have my inverse table, I'm going to go ahead and pause the recording and graph it. All right, so I've graphed my inverse table, and then I want to show you guys and kind of remind you that that's kind of really ugly. These two are inverses. You can tell on the graph because there is symmetry across this line y equals x. Losing my voice today. All right, so you can really see that in this picture too, right? These are mirror images of each other across this particular line, and that's, remember, how you can tell graphically that two you know, curves are inverses of each other. So if we wanted to actually find the inverse equation of this, you know, we learned a method last week, and it was called the switch and solve method, and we started by switching x and y. Now remember that this f of x is your y, so from y equals 3 to the x, we would switch, it to x equals 3 to the y. Now, from this point, what our next step was to solve for y and get y by itself. But the issue is that we actually don't know how to solve for y when it's in an exponent. We have not learned that. And so we're kind of stuck. We can't actually do this at this point. We don't have the knowledge to do it yet. So we don't know how to solve for y. When it's an exponent. All right. But we will be learning how to do that. By the end of this lesson, you will know how. However, we can play a little game here and say, well, what if we plugged in 81 for x in this substituted version? Okay, so in my x equals 3 to the y, if I plugged in 81 for x, then I can take a guess at what y might be, right? We can play around with our calculator a little bit and see if we can figure out 3 to the what power equals 81, right? Like 3 to the second power is 9. That's much too small. 3 to the third power, that's still too small. 3 to the fourth power. Okay, so we got our 81, and we got it by raising 3 to the fourth power. So I can say that the y value here is 4 because 3 to the fourth power equals 81. And that's what I wanted, right? 3 to the what equals 81. All right, so next we have these logs. Now, we will make the connection between those and like inverses and stuff in a little bit, but for now I want you guys to understand the relationship of what's even going on, what does a log mean, and looking at these numbers, hopefully you can see that there is a relationship between these three numbers, between the 2, the 3, and the 8, the 3, the 3, and the 27, and so forth. So here, if we look closely, we can see that if we raise 2 to the third power, we actually would get an answer of 8. Okay, if we look at this one, if we raise 3 to the third power, we would get an answer of 27. You can even check that, right? We saw it here. 3 to the third power equals 27. I'm so sorry, I keep coughing during this video. All right, here we can do 5 to the second power equals 25. So what we're doing here is a little trick called the circle of life, and we can always follow that trick to see how we can rewrite these log equation looking things in this more exponential format. So this one does the same thing. Just do your little counterclockwise trick and we figure it out. All right, so basically from looking at all these, I want you guys to recognize this rule here. Anytime we have something written in log form, let's say log has some little number here, this little number is known as a base. That's an ugly arrow. That little number is a base. So if we have log base something, and then there's a number in the parentheses, we're going to call that a, equal to something, right? So I'm just filling in all these as variables. This is what we call log form. All right. And then if we want to go from that format to exponential form, which is what these are, it's going to work with the circle of life again. So it'd be b to the x equals a, because we follow these arrows. And again, this is your exponential form. So this is something that you very well might want to write down. It's good to have this in your notes right here. This is like the key because you guys are going to need to be able to go between these two forms. You'll see what I mean very soon. All right. So now we're going to use that relationship to try and fill in these missing blanks. So let's look at this one. And anywhere there's a blank, you could just call it an X because like that's what we're looking for. So if I just pretended there was an X here and I followed my circle of life, I could say that 2 to the sum X is equal to 16. So that's when you have to kind of just play the game and be like, 2 to the what equals 16? We test it out. Let's just try 3. 2 to the third is 8. That's too small. So let's try 2 to the fourth, see if it works. And sure enough, 2 to the fourth does equal 16. So we got what we wanted. So we know that our answer is going to be 4. For this one, we can do the same thing. Pretend there's an X here, follow our circle of life, and we find that we need to know what exponent will get us a 32. So 2 to the what equals 32? Well, 2 to the fourth was 16, and that was still too small. So let's go ahead and try 5. Sure enough, that 5 brought us to the 32 we wanted, so my answer here is 5. Okay, this one, the missing spot is in a new place now. Let's just call this base as X, right? It's okay, any part of this can be missing and we can figure it out. So we can say X to the second power, we're still following my circle of life here, equals 100. Okay, so now this one could be pretty obvious to you guys. What squared equals 100? Hopefully you guys know that x would be 10 here, right? Because we can even test that out. We know that 10 squared gives us 100. And if you didn't know that, that's okay. You can, again, just test stuff out in your calculator until you find an answer that works. Like in this case, I would have probably just tested stuff out. If you did 6 squared and find out it's too small, 7 squared, find out it's too small, and just, trial and error. Okay, for this one, our x is in this spot now. So again, the process is the same. 5 to the third power equals x. This one's pretty easy because we don't actually have to play any games here. This is just something we could type in our calculator. You should get an answer of 125. Yep. All right, here we have an x in the base again. Follow our pattern. X to the fourth equals 81. We got to test it out. What to the fourth power would give me an answer of 81? Well, let's try 2 to the fourth. That is not it. 3 to the fourth. That one worked. 3 to the fourth gets me 81. So x must equal 3. And that's because 3 to the fourth equals 81. We got what we wanted. All right, this one, it's a little bit different. It would require you to kind of remember something from the last semester. But in this case, anytime you raise a number to an exponent and the answer comes out smaller, that means that the exponent must be like a decimal or a fraction, something smaller than 1. So here we could test stuff out still. Oops. Let's say if we raised it to the 0.3, right? Raise it to the 0.3. That's too small, so let's try 0.5. And sure enough, that's the 10 we wanted. So 0.5 is our answer here. And if you remember, if you raise something to the 1/2, that's what 0.5 is. That's equivalent to taking the square root, which is exactly how we would have gotten that 10. Okay, that's a connection to draw to first semester. All right, next, we can actually now, we have the information we needed to figure out the inverse equation from the front page, right? We ended up at x equals 3 to the y, and we were like, man, I don't know how to solve this for y. So now we do have the means to do that. So here, all we have to do, okay, is convert to log form. Anytime you're trying to find the inverse of an exponential function, you just have to convert to log form. So recall that log base b of something equals x, this is my format, is the new way to rewrite it, right? If we start there, we end up with this. So, and it can be a little trippy sometimes, so just go do it slowly and take your time with it. So in this case, we would have log base, the base is the thing that's raised to the exponent, so that's going to be my 3. And then the thing in the parentheses seems to be the thing on the other side of the equal sign, so for us it's going to be x. And then the exponent is always your answer. And the reason this works is because now we have solved this for y. We got it in y equals format, and that's what we wanted originally in the first place, right? So that's how we know that it is the correct inverse. So really I should rewrite it like this. Technical inverse form. All right, I have about 30 seconds left of recording, so I'm going to work these through, and I'm going to pause the recording while I do that, and then I will talk about them a little bit after. All right, I've worked these out. These bottom ones are basic circle of life problems from the previous page, so those aren't super challenging. These ones, though, these can be a little bit difficult, so anytime you're not sure, it's nice to, confirm them with your circle of life trick, and you're like, okay, yes, this checks out, so I'm good to go. So that's all for today.